In the Wilking Lab, one of our core technologies is light-based 3D printing, also known as SLA printing. This is a print method that is capable of printing very high-resolution, complex geometries. This all starts with designing the desired object in a CAD software. Once the object is designed, it can be exported into a slicing software. The job of the slicing software is to take your 3D object, slice it into many individual layers that can be read by the 3D printer. In the case of this object, it's sliced into approximately 150 layers, the entire print taking on the order 2 hours to complete. Here we're using a Formlabs Form 3 SLA printer. It uses a laser of 405 nanometers to selectively cure resin in a vat. Everywhere this laser touches the liquid polymer, it turns into hard plastic. Repeat this over and over again for all 150 layers, and you end up with your printed object. It can be removed from the build plate, rinsed in a bath of isopropyl alcohol, and then finally finished off with a UV cure. What you're left with is a hard plastic 3D printed model, which in this case has internal channels which we can drive flow through. The same technology can also be used for bioprinting. Here we have a PEG-DA hydrogel, which is a biocompatible 3D printing resin. We can add cells to this resin and use it for bioprinting applications. We hope to be using this in the future to investigate rules of spatial organization and interaction in synthetic biofilm and other fundamental biological research.